Hello, how are you out there? It's Mark, and welcome back to another GameMaker Studio 2.0 tutorial. Now, we had left off with essentially, I think the homework was trying to get more precise collisions so that your little hero character would bump into the orcs like at tighter tolerances, and ultimately you could get that down to single pixel accuracy. Now, I did not implement that myself. If you did it, that's awesome if you figured it out. But I'm not going to review that homework. Today, we are going to talk about doing a very simple lighting effect for tile based games. So think like Legend of Zelda, but where Link can carry a torch around and cast a light around him, and everything else is in darkness. Or a torch on the wall might cast light around it, or a bonfire or something like that. Or you could have a light spell that you cast that lasts for a certain amount of time. Here's the thing, this is like virtual lighting. It doesn't like cast shadows, it doesn't obey laws. It's a very simplistic uh, circular light effect, but we can do it in like maybe 10 lines of code. It's really simple to implement. So let's jump into that, and then I'll try and come up with a little bit of homework to assign you. We'll see what we can do here. So let's just run our program really quick, see where we left off here. This is recording? Yeah. Okay, here we go. So yeah, you can see, and still we kind of have chunky movements, right? We can only get so close to the orc, so let's not worry about that. But right now, our characters are really large on our game screen. So let's scale everything down by half so that we can get a lot more tiles into our game world without changing up too much. So let's do that by, first of all, going to our sprites. And we're going to go into the chest, and right now it's 128 pixels by 128 pixels. We're going to reduce this to a 64 by a 64. It automatically updates both because we have the maintain aspect ratio checked. Aspect ratio just means the proportion of height to width, or the ratio of height to width. 1:1 is what it is right now. So however tall it is, it's equally wide. So we'll just hit apply, and we've now, without actually changing our chunky pixel graphic artwork, it looks identical, but yeah, we've shrunk it down by half. Now let's go to the hero. We'll do that really quick. Same thing, we're going to click this resize sprite button, and we're going to change this to 64 and update and apply. And finally, to our object orc, our little mob orc. And if I don't know if I've explained this, the reason everything we work with is usually on a multiple of 8. So it's like 32-bit or 64 pixels or 256 pixels. Those are all multiples of each other. 8, 16, 32, 64, 128, 256, 512, 1024. It has to do with the fact that computers run on binary code, true or false. That's stored with 1 bit. It's a 0 or a 1. 0 is false, 1 is true. All modern computing functionally works this way. However, keeping track of millions or billions of individual bits is kind of a hassle, so they came up with what's called a byte. A byte is 8 bits all together. And 8 bits it's essentially 2 to the 8th power. So it'll start at 1. That's 2 to the first power. 1. Well, is it 1? No, it's 2. It 0 or 1 represents 2 values. So we'll say 2, 4, 8, 16, 32, 64, 128, 256. I think I'm right. Okay. So with graphics, it oftentimes turned out the same way. So to this day, most of the time when we're dealing with graphics, we will deal with something like a 32 by 30. You've heard of like 32-bit graphics? Yeah, something like that. Or when you buy a RAM memory stick or a little solid state USB drive, it's 256 gigabytes of RAM. And now we're up to like 1 terabyte, 2 terabytes, and 4 terabytes. Someday there will be 512 terabyte solid state hard drives. It's always going to go on a multiple of 8. That's just the way computers work. So history lesson resolved. Let's hit apply. Okay, let's run it real quickly. Look at that. You can see we've essentially, even though our graphics are still crisp, they're still nice and chunky, but we can fit a lot more of them on here. Now, the movement's still pretty large. Let's do this. Let's jump into our movement function. All we have in here is the startup function. We probably didn't need to make a startup function or put it into this little script file, but I think it was more to demonstrate how a function works is probably why we did this. So it's a little clunky, but let's just change the global mob step from 64 pixels to 32. We're going to cut this in half. There we go. Now we'll save. Always want to save in case your program crashes. Let's run it again. And now when we move, yeah, look, everyone's taking much tinier steps, right? There you go. So we've functionally made it so we can fit 4 times more tiles on our screen. Our game world is half the size, but 2 times 2 equals 4. So the old game map would have taken up this quadrant here, and there's a second quadrant, a third quadrant, and a fourth quadrant here now. We have 4 times the map area to work with on our game window. So we've essentially just scaled that so that our torch effect is a little more effective. What do we got to do next? Let's talk about, oh, no, let's make grass. Check this out. Let's make a new sprite really quick. I want to make a ground layer. So let's make a new create sprite. And I'm putting this in the sprites folder, and I'm going to name this SPR_grass. All right. And we will leave it at 60. Let's change it to 16 by 16 really quickly, just because it's quicker to draw. All of my little pixel graphics I do at 16 by 16 because I'm not a good artist. That's the only reason I do this. We will edit the image. Here we go. I am going to flood fill all of this with just straight black. And then I'm going to grab just like a nice lime green for grass. And I will simply draw, yep, pixel, 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 pixel. Maybe one there. Yeah, there we go. It's not much. It's just, this harkens back to, like, say, early 80s graphics, right? You only had like 4 colors, and your graphics were super simple because all the memory on your computer was probably like 16 megabytes or something. You had very little to work with. So let's now make an grass object. So we're going to go up to object. We'll go into our tiles folder. I made the tiles folder because I wanted to differentiate between tiles for the lighting effect, because I refer to tiles a lot in this tutorial. So these are objects that are in the game world, not on the game world. So imagine if you had a button, that would be part of your GUI, your graphical user interface. I'm not going to call that a tile, or like a progress bar or something wouldn't be a tile. Tiles are things that are in the world, like a chest, like a tree stump, like a fireball, like a kraken, or a river. Those are things in the world. Anything that's in the world, I'm going to call a tile for the sake of the tutorial. So let's make one new tile, and we will create object obj_grass. And all we have to do is come over here. We're going to choose the sprite we want. It's under sprites and grass. Here we go. I've noticed lately, the last year or so with GameMaker Studio, a lot of times my little icons don't refresh. I don't know why that is. If anyone knows how to like make it refresh, I think if I save my game and I closed down GameMaker and then reopened it, I think you would see the grass tile right here. But for now, it doesn't. I don't know. It's definitely a bug. It's not me. It's a bug in the GameMaker Studio. But it's minor enough to where I'm not going to worry about it. So there we go. We made a new object. Now let's go to our room. All right. And let's learn something new. Let's learn about layers a little bit. Right now, we have a background layer and an instance layer. Check this out. If I click on the instance layer, I can blind it, or show it or hide it. So those are all my instances, and I can do the same with background. There we go. So if I hide the background is just a black sheet. If I hide it, you've got the gray of the window here, essentially, of GameMaker Studio. Interestingly, with your backgrounds, if I click on it, you can choose different colors, right? I could jump in here. I could choose yellow, right? But obviously, we'll leave it at black. You can also do a couple other cool things. You can tile horizontally. So say you made like a brick floor pattern, right? Think like Contra or something, some old school game. You could just tile the whole background. It'd be static, but it's a simple. You could stretch an image to cover it, whatever. That's there if you need it. But one interesting thing about backgrounds or the layers is if I'm on the background layer, I can't actually click. Like I'm left clicking, I'm trying to grab the orc, the hero. I can't get them. I have to be on the instance layer to grab them. So let's create a new layer really quickly. And we're going to hit this plus sign, create layer, and we can do a new back. You do multiple backgrounds. Why would you want multiple backgrounds? For parallax. You think of your favorite pixel-based games where the mountains are in the far background, then forest trees are moving in front of them like this, and then you have clouds drifting across on the top. You can do all of that very simply by having just a couple of backgrounds with different graphics moving and doing cool stuff. I think you can maybe even have your background shift automatically. We'll look at that in just a second. But I digress. We wanted a new instance layer. It's called instances_1. Let's rename it ground because we're going to put the grass on this. So I'm just going to call it ground right there. And let's call this instance layer. Let's right click. Let's rename this one. We're not going to call it instances anymore. We'll call it I don't want to say objects. What's above the ground? I was sorely unprepared for this. Things. I'm gonna call it things, folks. I'm so sorry. Wow, that is a weak ass name. I say things as meaning things that are on the ground. There you go. That should make sense to you. Let's click on background again, though, real quick. I want to scroll down. I'm wondering if you can make it. Oh, animation speed. That's cool. So you can have an animated background. Oh, speed. Yeah. Look, you could set your background to like your X or your Y to a couple of pixels per frame, and so you could set your clouds to just slowly drift across the X-axis, and you could do really cool parallax things that way. So. Enough about backgrounds, but it's an easy way to make some cool stuff happen in your game. Let's jump to the ground layer. And here, I'm going to hide my things right now. So all the things are gone. Now let's grab a grass, and we will drop it over here. Oh, it's so tiny. Let's go back into our sprites. It's 16 by 16. Let's make it 64 by 64. We're just going to resize it. There we go. So we made it the same size as all the other graphics. There we go. That is our ground. It doesn't look like much, but it is good enough. And then we'll control copy. So control C, control V to paste it. We'll throw it in there. Let's do another one. Let's do another one. And then I'm going to shift and grab. And now I can control C, control V. So you see this is a really quick way to, like, if you got to do a bunch of tiling and you don't want to lay out 200 individual. And now let's shift and grab again. There we go. Control C, control V. Boom. Do another. This is a nice quick way to like just mock this up. And we'll go all the way to the edge. And we'll do, we don't need to do too much here. I'm going to just grab that. Nope. Right there. Control copy, control V. I'm just getting the last set. And now I will shift and grab all of it. Control copy, control V. And one more time. There we go. So we have just carpeted our world with grass. Now you'll notice, hey, the things, we can't see them. I'm going to restore the things, but if you look, all of our orcs, our hero, and our chest are being covered by the grass. This is a really nice, simple thing about your layers is that you can simply grab the ground layer and pull it underneath things. And look, the ground layer and the things layer swapped. Now the things are on top of the ground. You could even have another layer, say, like you could have an effect layer, effects, where something like a bird, like a little bird animation flying around, or a butterfly, or a fireball, these could all be on top of everything. So butterflies and birds and fireballs fly over everything. So you could have the ground, you could have your things, you could have like an item layer, which would be like buckets and daggers and coins. And then you could have a mob layer, which would be like your hero and your creatures. Then you could have an effect layer on top of that. And then you could even have like a a cloud layer where fog could float over everything. So really simple way to make your games come to life. And GameMaker Studio handles all that for you. You don't have to do any special coding. So now the last thing I'll do is just like I can hide the ground, show the ground. I can hide my things, show my things. It's a really easy way to kind of make stuff pop out, see what you've laid out. So yeah, use layers. Use layers. They're super simple. Okay, and actually, I will point out again though that I'm on the ground layer, and I want to move this chest into the grass, but I can't get it. I have to go to the things layer. There we go. Now I can grab the chest, put it down here. Pretty sweet. Let's run it again. Just let's save. Always save. Let's run it again. See where we're at here. We're 15 minutes in. I know it's long. There you go. And this grass isn't too bad. Less is more with pixel graphics, especially old school pixel graphics. So you kind of get the feeling like having that dark contrast makes everything else really pop. Now, to be fair, the orcs are green, so they blend in a little bit. But like the hero to me really stands out. The chest looks very crisp. So I really like if you don't have a lot of time to do assets, you're not some great artist, or you just don't have time to like do fantastic art. It's just a fun way to like mock up a simple game. I saw what's the game Moon Ring? Moon Ring is like a free to play old school pixel graphics game on Steam you can get. I don't think it costs anything, but it looks really cool. And they even did that with like a super reduced color palette. I think it's like 4 colors. So it's like they're emulating really old school. But yeah, I think this looks pretty fun. You can imagine having walls and wells and bonfires and pathways and your characters going on an adventure. I love RPGs. So we did all that just to like kind of make our world pop a little bit. Let's jump back into the grass sprite. I think it's a little too let's edit it. Let's cover over. Oh, seriously. Hold on. I'm changing this up just a bit. I feel like it's a little too repeating. Let's get rid of this one. All right. Let's run it one more time. I'm just curious if we can. There we go. I think that's a little less cluttered. And one thing when I'm tiling is I always want there to be like observable gaps so that you can kind of get an eye for the grid as the player. You kind of feel like now, this is I look like here's 1 tile, 2, 3, 4, 5, 6. You can get a sense for how far things are away. And as your character steps, you can see he's doing like half a tile at a time. So you never want your repeating pattern to be too uniform with your tile graphics. You want it to sort of have a grid-like effect, in my opinion. It makes the world more comprehensible to your user. This is my subtle opinion. But yeah, there you go. So now let's get on to this cool lighting effect. I mean, ultimately, we only need, again, around 10 lines of code to make this work. However, we're going to learn a new idea. Listen, we learned about layers, and let's learn about inheritance. Now, you've all heard of object-oriented programming. The idea with that is that you make objects like we're doing, and that they can share code between them. You can reuse code, write code one time, and have it used in many places. It's kind of the power of object-oriented programming, and an aspect of that is inheritance, meaning parents and children inherit from their parents, or like a family tree. Like there's your 2 parents, and then your parents have 2 parents each. So you can quickly multiply out, and to make a cool object. So anytime you want to inherit something, though, you want to make more objects to do it. Now I am going to I'm talking nonsense here. Let's make a base object called object tile. Object tile is going to represent anything that shows up in our game world that's part of our game world. Again, separate from like a button or a progress bar. Those are part of the graphical user interface. So let's do this. Create new object, and we'll just call this obj underscore, and I'm going to type tile all caps. Usually when I'm making a parent object that won't actually be in the game, like think of like if we made an AI object, artificial intelligence object, that all of our orcs and our green slimes, everyone gets an AI object that is their brain. You'll never see the AI object in the game world. It's just a piece of code that each orc and each green slime and each wyvern has access to so they can think and move around the game world, right? In this case, tile is the same thing. It's a parent object that there won't be any tile objects, but all of our other objects will inherit from tile. So we've made object tile. I don't even have to give it a graphic, I don't think. Now let's go into chest. We're going to come down here to the parent bar right here, click it, and we're going to go into and choose the object we want. And we see there's the objects folder, the tiles folder, and there's object tile, all cap. And now object chest parent is object tile. Let's do the same for object grass. We're going to come down here, parent, object, objects, tiles, boom, there we go. Let's do the hero. Yes, even the hero is a tile. Parent, right here, object, tile. Now, you can see this could take a really long time. If you had already made like 50 objects, yeah, you might have to go through and do them all. But actually, as you develop a game engine where you have movement rules, collisions, lighting effects, theoretically, you'll build out all these little bits of code. And as you add the wyvern, you add the red dragon, you add the fence, the tree, you're going to decide, hey, do you need an AI parent? Do you need a tile parent for light, a lighting effect parent, whatever. So as long as you kind of have, you never want to develop your game too far until you've gotten all the little bits of mechanics working. You want to do little samples. There's just a lot about what our tutorial's about before you take the time to spend 2 months building out this great world and you realize, oh shoot, I forgot to put in experience gain, and now I got to go add experience to all 128 of the enemies I made. Shoot, and you got to spend all the time typing it in. So build out your mechanics of your world first, the mechanics of the rules as well as the mechanics of the graphics, the game engine you're making. So yeah, we got it all done. Yeah, everyone now is a child of tile. And you can see here, parent, my parent is object tile. And let's go to object tile really quickly. Check this out. It's children. Will it show me? Yes. You can see now object tile's parent doesn't have a parent. It is the parent. But look at its children right there. Chest, grass, object hero, object orc. Pretty cool. So you could, if you dig in there a little bit, you can see who's inheriting from who pretty easily. Now that we've done this, why have we done this? Because we want to write one block of code that's going to enable all the tiles to have lighting effects. That's functionally what we're going to do. We're going to write it one time, and it'll apply to everyone. So let's go to what we're in object tile. Let's add an event called draw, the draw event. And have we done any draw events for anyone else? No. So here's the chest. The chest now has a grayed out event called draw. And you're going, well, why is it gray? Why isn't it white? Well, the reason is if I mouse over, you can see object tile. And specifically, you see this big circle with 2 little circles. That, and I mouse over, it says object tile. That graphical collection of circles means the big circle is the parent and the 2 little circles are its children. This tells us that, yeah, we are getting a draw event. We're inheriting it from our parent object tile. So, and if you wanted to see, you're like, well, what is that? Just double click it. It's going to open this up and there's nothing in here. Why is there nothing in here? Because we haven't written anything in this one. It's showing the same one. And if you notice up here, see where it says draw and the X, there's no lock. But if I go back to object chest, there's a lock. Why is there a lock? Because this draw event, I'm not supposed to type in here. I'm supposed to type into my parent's draw event. This one's locked off for me. If I look, I'm typing on my keyboard. You see the cursor? It won't let me do anything. It's like, no way. You can't edit this. Go edit the object tile parent if you want to edit your draw event. There's ways to unlock it if you need to, which we might get into. But yeah, so let's go back to our object tile. And what do we want to do here? The first thing we need to do, anytime we create a draw event, we're telling the GameMaker engine, hey, You usually draw for me. If I put an orc on the screen on the game room, you're gonna draw it for me. But when you make a draw event, you're overriding. You're saying, whoa, whoa, timeout, game maker. I'm in charge. I'm the captain now. Okay. And game maker is afraid. It knows. So we're gonna put in draw underscore self. Yeah, right there. And this is just a simple built-in function. And all this does, let's mouse over it. This function draws the sprite assigned to the instance exactly as it would be drawn if the draw event held no code or actions. Yeah, it's just saying, hey, because I'm taking all control, draw the graphics. Game maker, just draw for me. And then I'm going to put some more code in. Cool? Yeah. All right. So what's our next line of code? We want to... Wait, well, let's make a variable. We're gonna make let's make a variable called light, and light is going to be out to a certain distance. So in pixels. So imagine if we have a candle, our character has a candle, the light may only go out 30 pixels. Or if they have they cast the daylight spell, the light may go out to 1,000 pixels. It may cover the whole map, bright as day. Or you could have a regular what's this? You have the light spell might be like 120 pixels. Daylight might be 1,000, and a candle or a torch might be some other. You could have different numbers. You could turn the lighting effect on and off, or have it grow or shrink. Maybe as the daylight spell fades, step by step, it goes from 1,000 to 900 to 800, and the light slowly closes in on you. So you could do some really cool, easy effects like that. But let's make a variable then for object tile right here. Let's go to variable definitions. Let's add. Let's make it an integer, meaning just whole counting numbers. I guess I know I always get confused about that. And let's call it v underscore light. Sure. And by default, I'm going to set this to 0. No light. Why? Because the grass is affected by light, but the grass tiles, the ground, it doesn't provide light. It's just if it's dark, you don't see the grass. That's all. So by default, every object is going to have no light. Okay, now let's override the default 0 variable for our hero. Let's pretend that our hero, just by default, for the simplicity of our tutorial, is going to have a torch that works to 150 pixels. So let's go to the object hero, and let's go to its variable definitions. Is right here. Check this out. We've already given our object hero HP and max HP. You can see they're in white, but look at here is v underscore light. It's grayed out. Why? And it's also locked. I have to come over here to this, override this variable. I have to actually click this little pencil, and now look, V-light is now white, and I can adjust it to 150. Again, 150 what? 150 pixels, right? So if our character is 64 pixels, this will see out about 3 tiles. So let's make it a little more. Let's make it like, let's do 256. There we go. That's exactly 4 character lengths, right? All of our characters are 64 pixels right now, so that'll see 4 out in all directions. Pretty cool. However, we overrode that just for the hero. If I go to the orc, let's go to the orc real quick. There's V-light, grayed out, the value's still 0. So we didn't override it for the orc. What if we, why does this matter? What if we made a will-o'-the-wisp? A little glowing like a fairy or orb that floats around our world. We could give it a very faint light source of its own, of say like 64 or 128, where it's just a couple tiles. It's this dim little thing that floats around the world, lighting the darkness where it is. That would be cool. But yeah, for each creature, each spell effect, you could change the light pretty easily. I digress. Let's close the orky down. We don't need him. Let's go back to the object tile. So we haven't really written a whole lot of code. We made a variable called VLight. By default, it's set to 0. But up here in the draw cell, the first thing we're going to want each object tile to do is to determine if it's a light source itself. Hey, do I cast my own light? Because if I do, I am not going to be dark. I'm going to be well lit. I'm my own light. I'm a will-o'-the-wisp. Everyone can see me. So let's just make an if statement. If, let's build this out really quick. I almost always make the whole function block before I type it in. So we're going to say if, is it this? Self? What was it? Self? Oh, there it is. Yeah. Look. Self dot vlight is equal to, no, is greater than 0. Then exit this function. Exit? I think that, no, it doesn't like the exit's like a keyword. Let me see. Exit like that. Yeah, there we go. All right, what's going on here? So let's do a comment. We're gonna just say if this tile is a light source. I sure hope I'm spelling source right. I'm a terrible speller. If this tile is a light source, then exit. And all exit means is it leaves the current function or event. So if you hit exit, it'll leave the draw event and it'll continue with the code wherever GameMaker was in running the game. It'll just skip whatever comes next. So we're just checking real quick to say, hey, are you your own light source? If you are, you don't need to do this. Just bail out. You don't need to do this light effect. Simple. All right, what else do we need to do? So that's a little bit of the code we have to do. Now we want to measure the distance to the nearest light source. So let's just make a variable. Do I have to? Let's see. Yeah, let's go variable dist. Now we'll say distance. We'll actually do it right here. I don't think distance is a keyword. And let's set distance to 10,000. Just a big number. Bigger than our map. We know that our game window is like about 1,000 by 1,000 roughly, or 1,500 by 1,000. So by saying 10,000, we're saying like huge distance. Just defaulting it, and then let's get the distance to the nearest light object. Ooh, yeah. Here, check this out. Let's say, okay, so we're gonna say distance equals. So we're gonna store some value into distance. We've defined it as having a value of 10,000, but now we want to find some other thing. So let's go distance. I'm gonna start typing again because I saw some functions come up. Yeah, right here. Look at this distance to object. This distance is the one we just defined. It's a real. This top distance is this one we just typed. Just so you know where'd that come from. We created it. But below it is distance to object, and we will put that there and we'll put a little semicolon. Now, what does distance to object want? This function calculates the distance to the edge of the bounding box of the calling instance, meaning, imagine this is the orc, and the orc wants to know how far he is away from a light source. So the calling object would be the orc to the nearest edge of the nearest instance of the object specified, meaning in this case, object tile? No. Let's make another parent object called object tile underscore light. Oh, I misspelled light. There we go. Yeah. Why? Because why are we doing this? Because we're essentially saying, hey, every tile in the game world is going to see if it is a light source. If it is, then it's gonna kick out a draw. It's gonna stop. It already drew itself. It's not gonna do any more lighting. However, if it's not a light source, if it doesn't have its own light, it now needs to see how far away it is from the nearest tile that is a light source. So we're gonna make another little parent object. Let's go to our tiles here. Right click, create object. You're gonna need to do this as well. And this one won't really need any code though. We're just making a object placeholder, right? Like it's ancient history and the genealogy of all of our objects. If this is one of your ancestors, this is a genetic trait you've inherited, right? It's just a trigger we're going to give it. We're going to call this object tile underscore light. There we go. Boom. Now, every object tile light is going to inherit, its parent will be object tile. So I'm going to come in here to objects, tiles, tile. So even an object tile light inherits from object tile. So every tile is a tile, but not every tile is an object tile light source. That's the subtle difference. So check this out. Now let's do this. Let's go back to our object hero. And you know what? You are not only do you inherit from object tile, you actually inherit more recently from object tile light. Because our hero in our demo is going to have a little torch he carries around that lights out to a range of 256 pixels. Cool. So he's the only one. Only our hero has a special ability. We can check that by going to object tile light. The only child that has is object hero. None of the other tiles inherit from object tile light. But if we go back to object tile, check this out. We inherit from, oh, look at that. The chest, the grass, the orc, and then the subcategory of object tile light, now object hero is in there as well. Look at. So we could have other light sources. Remember we're talking about the will-o'-the-wisp? Will-o'-the-wisp would be underneath this subcategory. So we're making categories within categories, classes within classes, or you can think of like in the world, the tree of life, genus, species, family, right? All those categories. That's all we're doing here. The great thing though is that our object tile light we created, we don't have to put any code in there. All we had to do was to say who its parent was and then assign it some children. And this should, fingers crossed, this should work. I have not, although I've messed with the lighting effect, I haven't done it this way with the object tile light. So this is literally new. I'm testing this out with you right now. Let's go back to object tile light. We're still writing our 10 lines of code. It's just taking us an hour to do it. So sorry, sue me. So yeah, this should work. What this is going to do then is the orc is going to find out, hey, how far away is the nearest object tile light? In this case, the hero. The hero is the only one out there. So what are we going to do with that? Well, we're going to say, listen, if we are close enough to the hero that we're inside of the hero's torchlight, the 256 pixels, we're going to get some light. If not, we're in the pitch blackness. So we need to just make another if statement. If, boom, then, and again, I'm gonna mock this all up. There we go. And we're gonna say if distance is less than or equal to the object tile light. Oh, I gotta be careful here. Oh man. Okay, I just thought of something. Is it gonna know what happens if we have more than one object tile light? Shoot. We might need slightly more than 10 lines of code. Here's the deal. For this example, we've only got one object tile light. The hero is the only one. This will work. So let's run it. Let's run it and make it work. And then maybe we can generalize it to work with multiple light sources. Let's make it work with one light source first, okay, just to keep it simple. So if you are less than or equal to object underscore tile lights dot v underscore light. So you know when I do my crazy little abbreviations, like I do like SPR underscore for sprite or OBJ for object, I do v underscore so that when I type v underscore, all my light variables pop up. Because if I don't do that, look at this. If I get rid of if I just type in v, look at all this crud that pops up here. All these functions. But I know that if I do v underscore, I just get the one I want. So he's saying, yeah, if the orc is within the radius, the light of the hero in this case, we're going to do some more code. We are going to say we need to create another variable. Yeah, hold on. Let's see here. I don't know what I call it. We're gonna do alpha blending. The way this works is by making the graphic more or less transparent in putting blending it with a color underneath. All right. So let's make a variable really quick called var alpha, and we will set alpha to 1. No, alpha to 0, meaning no I can't remember if 1 is full transparency or 0. I think 1 is fully opaque and 0 is fully transparent. We'll find out. I could be wrong. I really don't know. Why am I getting a little effect right there? I'm getting a little defect. Oh, equals. There we go. Okay. We made a new variable called alpha. It's going to be the alpha value. So we're going to say that alpha equals. We need a value between 0 and 1 to describe the alpha channel when we're rendering our graphics. This is true for pretty much any graphics engine. You can't put in the number 25. You shouldn't put in the number -3. It wants a value between 0 and 1. Well, how can we do that? Listen, we're going to say, let's divide the distance by how far away the distance by the overall light source, meaning how strong is our torch, 256. So we're going to say distance divided by, as you use the backslash, object underscore tile light dot v underscore light. Now, why will this work? Well, we know that the distance can't be less than 0. Oh gosh, you divide. You can divide 0, but you can't divide by 0, right? Yeah, okay. We know that. Well, what if v light is equal to 0? Aha. It won't be because why? Because any objectile light, we better remember to set to more than 0, or it's gonna crash. You can't divide by 0. But yeah, we're not having anything inherit from objectile light unless it's greater than 0. You could write a little more code in here that says, hey, check to make sure that the light source is greater than, like up here where we're checking this stuff, we might want to do some extra checking. But for now, this will work. But anyway, it's going to be between 0 and 1 because we've already exited. We've already checked to say, is the distance less than or equal than the v light? So that means this value is going to be anywhere from 0 up to 256. If it's with, say, 500, this if statement would fail and it would skip this. So this should work. Oh, hey, let's throw in a little more code right here. We'll say if distance is less than this, and here we go. Here's our error correction. And object tile light is v underscore light is greater than 0. There you go. Look what we just put in that error correction. So it's never going to get to this division here if v light is equal to 0. This will keep us from crashing out because, again, the computer won't let you divide by 0. So we're doing 2 checks. Hey, is the distance less than within the torch light, and is the torch light greater than 0? That matters because if we were, say, if the torch had burnt out, the hero may have a light source, but we may set over time, may decrease, shrink until it hits 0, in which case our game would then crash. You'd walk around for 256 ticks, the torch light would get dimmer and dimmer, and then you'd hit 0. When the torch went out, the game would crash. That would be a bug in your code. So we've accounted for that. Still just the line there. All right, how many lines are we at? 1, 2, 3, 4, 5, 6, 7. I think we can still do it in less than 10. So what's the last thing we need to do? Is draw this tile, whatever it's, the orc tile, the chest tile, the grass tile, with its alpha blending set. We can do that with draw underscore, is it sprite? There's an instance. Sprite. Yes, right here. Sprite ext. I think ext means extended. So look here, you have a draw sprite, very basic function. Sprite subimage xy. Simple. But draw sprite ext or extended has sprite subimage xy, x scale, y scale, rotation, color, alpha. It just boom, there. That's the one we're going to do. Put a little semicolon. So inside of this, let's mouse over this. This function will draw the given sprite as a function of draw sprite, meaning it's like draw sprite, but with additional options to change the scale, the blending, the rotation, the alpha of the sprite being drawn. Rotation is actually cool. And imagine if you had an arrow graphic, right? You when you made the graphic, you draw the arrow straight up and down, and then you could rotate the arrow with this function so that it would fly through the air at an angle towards, and that the arrow would actually be pointed as it flew, or fireball with the fiery tail. The head of the fireball would lead the charge, and the stream of smoke behind it. So rotation is a really good way to do that. We can also do the blending, which is what lets us add color. Like, say we wanted to do a blood red tint to everything because you're in a boss fight against some dreaded, demonic lord, and everything's in this reddish tint. You could draw all your graphics with this draw sprite extension, and you can blend a little red color over something like that. Yeah, so there's ways to do it. In this case, let's start typing out. Let's right here. So we want this whatever sprite we've assigned to our object. So if it's object orc, we want the sprite orc. Well, how do we get that, right? Because we have grass, we have chest, we have the hero. We're gonna have hundreds of tiles of different types. How do we get the name of it? We're gonna use sprite underscore image index. Yes. This is an asset of GameMaker sprites, and if I mouse over this, no, let's see, asset sprite. Yeah, I mean, this is it. This is just one of those keywords. You see, it's green. It's a reserved word. Sprite underscore index simply says, hey, whoever's calling me, whatever object this is, tile, orc, whatever, use the sprite you're assigned to. So there you go. Now bear in mind, the tile itself, the parent object tile, does not have a sprite, but its children do. Orcs, heroes, grass, chest, they have sprites. And then the next thing, we just need the subimage. Subimage means when some images are static, like the chest doesn't have any animation, but our orc and our hero have multiple frames of animations. We did. Look, let's go to the sprite for the hero. Look, edit. Here's 1, 2, 3, 4, 5 frames of animation. Which one do we draw? Remember, we're completely overriding the draw function here, so we do need to control that. Normally, GameMaker animates everything for us seamlessly, but in this case, we've taken control. We're the captain, so yeah, we need to tell it. Is it index? I think it's index. Image index, object index. I think it's image index. No, let's see. What does this do? Built-in variable holds the current frame of the instance's animation. Yeah, there you go. It's the animation of the sprite there. So you see, it's another reserved. It's in green. It's key. It's not a keyword. It's a built-in variable that GameMaker provides. We don't define it. Like up here, we defined alpha variable. We defined the variable distance. But no, these are any sprite or object we make is going to have a sprite index. It's going to have an image index. But that'll make it so that our work is still animated. Let's keep going. Let's go to the next one. X, just X. It's green again. Why? Because it's this object's X. It's this object's Y. It's all boilerplate. It's pulling it from the orc. It's pulling it from the chest, from whoever. What else do we need? We need scale. This would be an easy way to encode, stretch, or shrink or enlarge your graphics. Now, when we wanted to shrink our graphics today, we went from 128 pixels to 64 pixels. But this would be a way to encode in the code while the game is running, dynamically make your objects bigger or smaller. I'm thinking of Slay the Spire 2. In Slay the Spire 2, some enemies shrink and some things get bigger depending on their buffs. But you only use one graphic, right? It's not like Slay the Spire made little graphics, medium graphics, big graphics. No, this is one graphic that gets shrunk or whatever. If you put 1 in there and 1, your X scaling, your Y scaling, just leave it 1. That means it's 100%. It's 1-to-1. We're not going to make it bigger. We're not going to make it smaller. Let's keep going. Rotation. I can't remember. Let's mouse over. Rotation. Down at the very bottom. ROT. The rotation of the sprite, 0 equals right way up. 90 equals rotated 90 degrees counterclockwise. So that way, right? The clock tick, tick, tick going backwards. And you could go to 180, which would make it upside down. 270 would make it pointed that way. And 359 would make it nearly back straight up. Although zero is straight up. Zero is 12 o'clock. 359 ticks would be 1 second off of midnight on a clock. So we're going to put zero in there, just straight up and down. Normally orientated. Our orcs aren't going to be running around like this, right? Running sideways. What else do we got? Color. So for this simple light effect, we are blending black onto all of our graphics that we draw because we want it to look like darkness or shadow. So we're going to say C underscore. When we do C underscore, we get a bunch of built-in constant colors. You see that it's constant in red, constant color right here. Constant black, blue. There's about 20 of them. Yeah, these are just really simple ways to get quick colors from GameMaker Studio. You could do way more. You could do tens of thousands of colors, but this is so that you don't have to be like RGB, right? You're like it's 27 red, it's 111 blue, and it's 14 green. You don't remember that, so you just say black right here. Excuse me, and then finally alpha. Well, we literally already made a variable called alpha, so we're just going to type in alpha. Boom. There you go. And you see it's yellow because it's this variable here. So what is this doing? This is saying, listen, I want you to blend the orc graphic completely with black based off of how much alpha, how transparent the black is, right? So if alpha is, let's see, how does alpha work? Alpha. From 0 to 1, where 0 is transparent and 1 is opaque. So if alpha equals 1, it's completely opaque. You can't, and up here we actually set alpha equal to 1 to start with, meaning total blackout. You can't see it. If it's down to 0, you will see it completely. And this is the example we were talking about. What if your distance was 0 or 1? Then when you divide it, it's going to be functionally 0. I guess, is that right? I think so. I think I'm doing this right. If I'm not right, this isn't going to work. So let's find out. I think we're done. Ignoring draw self, we have 1, 2, 3, 4, 5, 6, 7, 8. Eight lines we typed out. Let's run it. I don't think it's going to work actually. Oh no, it did work. Oh, it just worked. That's so cool. Let's move. Oh my gosh. In here, how bright can I get? Look at that. When we're right next to the chest, it's full lit. And look at this orc down here. He's in the shadows. And you see very clearly the torchlight is moving with us. We duns did it. Oh, that is so, I'm so pleased. But you see, there's no shadows, right? Or like if there was a wall, the wall wouldn't stop the light. This is so simplistic. It's like virtual lighting effect. It's so simple that the light is going to travel over or around anything. No shadows. We could probably find a way to like code a fake shadow using the rotation. We could make like a black silhouette of the orc, and then we could rotate where we pin it to the orc's feet, and then we rotate the shadow so it, depending on where the light source is, and angles, some geometry, we could figure all that out. But for now, yeah, that's 8 lines of code to do a very simple, like imagine if this was Legend of Zelda, right? Just Legend of Zelda, the first game. But Link had a light source like this. I think they did. Did they do that? Aren't there torches in Legend of Zelda? Or does it light the entire room? Or does it light? I can't remember now. Ooh, that's a shame. I spent a lot of years playing, but it's been too long. That's it. So the only other thing I would wonder is, I know we're an hour on. I'm trying to think if I should assign you guys homework. I'm afraid this goes a little beyond beginner tutorial. I mean, so the things we learned in this tutorial is we talked a little bit about layers, and we learned about inheritance. That's what we were trying to learn in this one. The truth is, though, a lot of the code we did here is using pre-made GameMaker functions like distance to object or draw sprite extended. We didn't write that code. But let's try this. Let's make let's do a quick will-o'-the-wisp. Yeah, what the heck. If anyone has had enough, by all means, you could stop watching the video. Let's do a little more. Let's go to sprite, create sprite. Let's call it SPR underscore will underscore O underscore wisp. Yeah. Let's go here to make it 16 by 16 real quick. Jump in, edit. We're just going to grab a little yellowy thing. We'll make a little sphere. Yeah. And then we'll grab sort of a pale, more pale. And we'll make it littler. And then we'll put this one here. And let's add a frame. Yeah. And then let's do the yellow again on this frame. And we'll move it here. And then let's grab this one and we'll do it here. And let's do one more frame, add a frame, click on here. Let's do, check it. I'm kind of making it like swing around, like rotate around itself, right? There we go. Boom. And now if we run it, yeah, so okay, so that's our will-o'-the-wisp, right? And let's actually slow that down a little. Let's set that to 5 frames per second. Okay, that's cool enough. Good enough. And do we do what's our alignment on these? I'm trying to remember. Middle center. Let's go back to the will-o'-wisp. Let's make that middle center. Cool. We've got a graphic. So let's go back up to our tiles. Let's create a new object. All right. Let's call it object will underscore O underscore wisp. Sure. Wispo. Let's set it sprites will-o'-wisp. Okay. Let's make it a parent. Whose parent is it? Is going to be object tiles, object tile light, right? Because this is a light source. Boom. And let's overwrite its variable now. Let's go into here. There's light. We need to click on the pencil to override. And we're going to make this one's light source 128. So 2 tiles instead of this half as bright as the hero's torch. What's going to happen when we do this one? Well, let's add a will-o'-wisp. Hold on. Let's jump into the room. And we're on the things layer. Let's grab a will-o'-wisp. And we'll put it over here in the corner. Yeah. And it's the tiny one. Hold on, let's resize the wisp to 64 by 64. I know, I always forget to do that. Okay, here we go. Let's see what happens. I don't think it's going to work right. Oh my gosh. It's here, watch. It's working-ish. It's not quite working right, but it's not bad. I'm waiting for an orc to walk over there. Where are the other orky porkies? Come on, guys. Oh, and I wanted to see someone else walk into the wisps thingy. That's pretty cool. It does work. It does work. Why? My concern is I really want that. I'm sorry. I want this orc to walk into the light source real quick. Walk over there, you sons of beeps. Oh. I want him to go over there. Go into the light. Go into the light. Oh, I'm pushing on him. Hold on. Go. No, you go. Go. Sorry. What I'm trying to see, what I am seeing wrong is that the will-o'-the-wisp light is the same as our light source. This should be half as bright, but it's not. So why is that? I mean, it's cool that in general it's working, right? But what's going on? Maybe homework. It might be too tough. It might still be too complicated. This is what the deal is. When we get the distance to the object tile light, is it grabbing the nearest instance? This function calculates the distance from the edge of the bounding box to the nearest edge of the nearest instance of the object specified. Oh. Okay. But then why isn't the will-o'-wisp have a tinier light source? In general, it's working, but yeah, this is why. This is why. Look at this. Distance to object does find the nearest tile light. However, when we call object tile light here, we're just randomly saying, yeah, go find whatever the last object tile light we added. Is it the last one in the room down here? The first one you find? I don't know. We're not defining that at all. This is a little coding. This is where coding gets tricky. Distance to object knows to find the nearest light, but this doesn't. This is generic. So what we want to do is, can we object check for? Yeah, check this out. We want to grab. Let's make a new variable called nearest light, nearest underscore light. Boom. All right. And now let's do this. Copy this, control copy, boom, boom, boom. Nearest underscore. Oh, it's right there. Right there. Light. Is that correct? Let me see. Let's calculate the distance. Object, the object check for no. Distance object. No, we want nearest object. Hold on. Oh, bear with me. We're one line of code from making this work. The distance to object isn't what we want. We want nearest of this type of object. So let's say instance underscore active change copy create deactivate. Like I literally don't know what this is called. Furthest? No. Ooh, furthest nearest. Yes. Instance nearest to me. And the instance in particular we want to find the closest object tile light. And then what else does it need? The XY? Oh, it needs the XY first. What's the XY for? This function will check all the instances of the given object type to see which is the nearest to the given XY point. So if we're the grass, we're going to use RXY of the grass and say, who is the closest tile light to us, the nearest light source? So we're just going to say XY. There you go. Now we have the nearest light source, and we're still going to get the distance from whatever the nearest light source is because this automatically knows to do it. So here we go. But we got to change out this one to this one. Check. We're going to take nearest light. We're going to hit control copy. And now don't change these in here, folks. Don't change these. Only change this. Control V, and control V. And the reason is because we're finding the nearest light source specifically, and then we're seeing how this is going to get us to 128 light, not the 256 light of the hero. So now when we run this, the will-o-wisp should have a smaller light radius, and then we'll finish up. This will be like exactly 1 hour here. Here we go. Let's run it. Fingers crossed. Did that work? Yes. Yes, it did. Look at how small that light source is. It did work. I'm seeing like a bizarre kind of interaction between the hero and the will-o-wisp, right? Do you see this? You see that line right there? What's going on is we're close. We're close. But yeah, in general, this is doing what I want it to do. But yeah, somehow when we get the two of them too close together, oh, look at that! Look at that cool shape. Oh, I'm loving it, folks. It is more or less working. And there we go. Maybe that has to do with like the 10,000. I'm going to call it good for now. You folks can mess with it. Something's going on in there, though. That's given a little interplay. Maybe what we need to do is take the nearest light, variable that's storing this nearest object, this nearest light object, and put it into this. Maybe it's getting confused between the hero in here and the will-o-wisp here, or something like that. It's conflating their distances. Let's try one more thing. Hold on, nearest light. Let's try one more thing. Copy. I'm going to replace this one real quick. Let's run it one more time. Fingers crossed. No, it's, yeah. You see, look at that hard edge right there. Oh, why is it doing that? Maybe this is subtly. You see how hard the edge is? Oh yeah, it didn't. That didn't help. That did not help. Okay, I'm gonna call. Let's just change this back. Let's go to object timeline. Hold on, right there. No, right there. I broke it worse than it was working. Let's call that good for today, though, folks. In general, this is kind of doing what we want with some artifacts, but I will see if I can find a way to fix it up. Maybe make it work better. But in general, that's still pretty few. That's like 10 lines of code. We might need something else. I don't know what, but I'm not going to hold you folks up anymore. If you watched along, thank you. But that was some real time coding and experimenting and troubleshooting. And then a lot of times to figure stuff out and get it working exactly the way you want, it takes debugging. It takes debugging and thinking your way through it. But if you watch, thank you so much. Take care, folks. Until next time.